Last year, you needed a supercomputer, or at least a server room full of humming GPUs, just to think about building a decent AI model. But this year, a tiny 7 billion parameter open-source model from China just stepped into the ring and started knocking down AI titans 10 times its size. No, this isn't sci-fi. No, this isn't some hacky benchmark trick. This is Miracle VL7, and it's real, it's lean, and it's dangerous. In just a few short months, this featherweight vision language model has outperformed models 3 to 10 times larger on real-world tasks, matched industry leaders like Gemini Pro and Claude 3 on reasoning and grounding, and proven you don't need to be OpenAI or Google to shock the global AI scene. How? It's not just the model, it's the mindset. Miracle VL7 was built with surgical precision, lightweight, multilingual, robust under pressure, and designed to reason out loud like a digital Socrates. And the story of how it was trained is wilder than a Silicon Valley IPO pitch. Let's go under the hood of the most unexpected AI upset of the year. Section 1. What is Miracle VL7? First things first, what exactly is Miracle VL7? Think of it as a vision-language fusion engine, a model that sees what you see, reads what you read, and speaks back in full, coherent sentences. Imagine pointing it at a blurry receipt, a crowded street photo, a chemistry diagram, or even a paused frame from a YouTube video, and having it tell you exactly what's going on, step by step. Not just what something is, but why it matters. That's multimodal reasoning, and it's the holy grail of AI in 2025. Most models that can do this well, like Gemini 1.5 or GPT-4 weigh in at 30, 70, or even 175 billion parameters. But Miracle VL7? Just 7. That's one digit. 7 billion parameters. It's like if someone took a Vespa and somehow beat a Tesla Plaid in a drag race. What makes this even crazier? You can run Miracle on a high-end gaming rig. No cloud cluster. No subscription. Just download the weights, fire up your favorite inference tool, and watch it work. It's fast, it's light, and, here's the kicker, it doesn't just spit answers. It thinks out loud. Chain of thought reasoning. Step-by-step math. Diagram interpretation. Even sentiment analysis inside memes. Miracle VL7 isn't a chatbot. It's a portable lab assistant, personal tutor, and visual analyst rolled into one. And that's only the beginning. Section 2, Architecture Breakdown. So how did this lean machine get built? Inside Miracle VL7, there are 3 primary engines humming along. 1. High-Fidelity Vision Transformer, HFIT. This is the model's eye, and it's sharp. HFIT can process 224 by 224 images at native resolution. That means no blurry downsampling, no chopped corners. Every pixel counts. 2. Adaptive Translator Layer, ATL. You can think of this like the UN translator between visuals and language. It takes raw vision embeddings and translates them into a form that the language model can reason about, smoothly and in context. 3. The Language Brain, VL7 Core. The heart of the system, trained not for quick chats, but deliberate reasoning. VL7 Core was built from scratch, tuned for chain-of-thought logic, analogical reasoning, and contextual memory. No short blurts, this model's comfortable talking in pages. Each of these parts doesn't just do its job, they communicate constantly, tossing insights back and forth in real time. It's like a newsroom with a reporter, editor, and anchor all on speed dial, constantly fact-checking each other. And none of this happened by accident. Miracle VL7 went through a training journey that most AI teams wouldn't dare attempt. Let's walk through it. Section 3, 4 phases of training. Phase 1, the vision warm-up. Here, they froze everything but the vision translator and fed in 400 billion image caption pairs. Not just Instagram perfect shots, but distorted, blurred, off-angle, and handwritten images. Why? Because real-world data is messy. The model had to learn that a crumpled takeout receipt with a greasy fingerprint still means meal expense. That a shaky photo of a license plate is still a license plate. It started rough, like watching a toddler try to read a cereal box, but by the end, the model could caption street scenes in Mandarin, English, and Arabic, all with regional context. Phase 2, Vision meets text. Next, they unfroze the vision transformer, and introduced textbooks, PDFs, technical blogs, and multilingual Wikipedia dumps. Another 250 billion tokens of mixed media. This is where Miracle learned that an image of a cell diagram might align with terms like nucleus and mitochondria, not just green blob. The model stopped guessing and started understanding. Phase 3. The data avalanche. Here's where it gets crazy. They fed in 1.8 trillion tokens, including screenshots from apps, captions from TikToks, diagrams from aerospace manuals, cooking videos with step time-stamped instructions, ancient documents, scanned and OCR'd. And they cranked the model's memory, its sequence length, up to 32,000 tokens. That's enough to hold an entire ebook, a video scene breakdown, and still have space left over to explain everything. And then, Phase 4, Synthetic Logic Bootcamp. They injected reasoning challenges, math proofs, ethics debates, coding puzzles, and multi-hop questions. Each one written out step by step, showing the how, not just the what. This trained the model to speak its thoughts, not just blurred answers. At this point, Miracle could take a physics diagram, a problem prompt, and a full paragraph of text, and output not just a solution, but the logic chain leading there. It stopped being a model and became a reasoning agent. Section 4, the Reinforcement Gauntlet. Now, here's where Miracle went from really good to are you kidding me? After training, the team threw it into a real-time reinforcement learning gauntlet called Raptor, reward-aligned policy training over responses. Catchy, right? Here's the twist. Miracle answered new questions, and instantly got rewarded, or punished, based on 2 criteria. 1. Objective accuracy. Did it get the math right? Did it click the right part of the GUI? For these, automatic scripts verified success instantly. 2. Subjective human preference. For open-ended tasks, like summarizing or giving feedback, human-labeled models scored the response. But instead of batching feedback over days like most labs do, Miracle got real-time updates. Every answer taught it something. Immediately. This on-policy learning, with feedback latency measured in milliseconds, made Miracle adjust mid-flight. And to prevent cheating, they scaled rewards by answer length, so it couldn't just spam long replies to earn fake points. The result? Benchmark jumps that even shocked its own developers. Section 5, Benchmark Carnage. You want numbers? Let's talk numbers. On MMU, a mixed modal reasoning benchmark. From 61.3% to 64.8% after reinforcement. On CharVision, a document plus diagram test. From 52% to 55.7%, matching models 10x larger. On Vision Trick, a gotcha image set designed to fool AIs. 78.1% accuracy, nearly unheard of at this size. But here's the shocker. On Video QA Lite, a subtitle-free video test, Miracle hit 68.4%, beating Ellavia 1.6 and even coming close to Claude Sonnet. And on WebBench GUI tasks, where models have to read and click web pages, Miracle nailed 82%, even identifying icons inside weird layouts and mobile views. all with 7 billion parameters. No fine-tuned Frankenstein ensemble. Just one clean, unified model. Section 6, the Personal Shopper Demo. In one jaw-dropping demo, the team gave Miracle a shopping site screenshot and said, "Pick the red electric SUV with sunroof and put it in the cart." No code. No hint. Miracle parsed the image, clicked the right trim, selected options, pressed Add to Cart, and generated a JSON trace for an automation script to replicate. It's not just smart. It's operational. That's why developers are going nuts. It's one thing to answer questions. It's another to use your eyes and hands like a human. Miracle does both. Section 7, Final Takeaways. So here's the 3 big lessons Miracle VL7 teaches us. 1. Curation computation. Thoughtfully designed data beats brute force scaling. 2. On-policy learning is a game changer. Real-time reward makes smaller models smarter, faster. 3. Small models can lead the charge. If trained right, 7B models can dethrone 70B giants. We're officially in the era of tactical AI. The days of needing a billion-dollar budget to innovate? Over. And if one Chinese open-source team can do this, you can bet others will follow. So what happens next? Will small, smart, open-source AIs take over enterprise workflows? Will megamodels like GPT-4 need to scale down to stay relevant? And will Miracle VL7 be the first of a new AI species? Let me know what you think in the comments. Subscribe, hit the like button if this opened your eyes, and stay tuned, because the next AI underdog might just make this one look slow. Catch you in the next one.